Section 4.1 is on inverse functions. What does the word inverse mean to you? Opposite, yes. Opposite. Okay. What is the opposite of multiplication? What's the opposite of addition? What's the opposite of a function? So it depends, right? If it has an exponent, it might be a root. If it has addition, it would be subtraction. But we want to invert everything. So if you had to guess, what would you say is the inverse of 3x minus 2? Yeah, you have to inverse the addition and the multiplication. Which one do you inverse first? Yeah, it's opposite of order of operations. We invert the subtraction before the multiplication. But what we're going to say is usually you plug in an x value. What's your favorite x value? 1, sure. And what do you get? 1? Oh, that's not a good one. Let's pick a different one. I heard 3. Okay, what's 3 times 3? Minus 2? 7. This function, you plug in 3 and gives you 7. What would the opposite of that be? Plug in 7 gives you 3. This is one way to think of inverse, 7, 3. If we can switch every ordered pair, then we're going to invert the function. Okay, let's plug in a few points just so we can see this in action. X, f of x. Let's plug in 3, 1, 0, -1, -3. We plugged in 3 and got 7. We plugged in 1 and got 1. 0 would give us -2. -1 would give us -5. And -3 would give us -4. So this corresponds to the ordered pairs 3, 7, 1, 1, 0, -2, -1, -5, -3, -4. How do we reverse the process? Flip x and y to give us 7 to 3. 1 to 1 is fine. That's the same. -2, 0. -5, -1. -4, -3. So if we try to construct the inverse of this function, we'd say, it looks like 3x minus 2, but if I flip the x and y coordinates, it looks like x is equal to 3y minus 2. Does that look familiar? If I flip the x and y, it's the same as flipping the coordinates. So now I solve for y. So I undo the subtraction first and add 2 to both sides. 3y is equal to x plus 2. How do I get y by itself? Divide by 3. Y is equal to 1/3 x plus 2/3. And this is our inverse function. Okay, do you believe me it's inverse? How could we check? Plug in x value, get the y value. We could check this by plugging in 7. What's 1/3 times 7? 7/3. What's 7/3 plus 2/3? 9/3, which is, that's what we wanted, right? This works for all those ordered pairs. We flip the ordered pairs by flipping the x and y variable. Any questions about that? Is the original line a function? If I were to graph 3x minus 2? Yes, why is that a function? Yeah, it passes the vertical line test, right? 3x minus 2, y-intercept of -2. Up 3, right 1. Oh no, undo. Okay, up 3, right 1. So this is the original function f of x. What's the inverse function? This is like the point 2, 5. This is a point 1, 1. This is a point 0, -2. So if we flip those ordered pairs, we would get 5, 2. If we flip 1, 1, we get 1, 1. If we flip 0, -2, we get -2, 0. Okay, so this is the inverse function. And it turns out the inverse of a function is a reflection over this line, y equals x. All right, any questions about this? So that means it should be symmetric about that line. Why are you erasing?
Scribble erases.
Oh, really?
Yeah, that's that.
I can't disable that? So if I scribble, it erases? Just doesn't work when I want it to. Oh, wow. Okay. That's annoying. Inverse function. We have three things going on here. You can think of it as changing the order of pairs, changing the x, y value in the function, or a reflection over the line y equals x. These all mean the exact same thing. Are we comfortable with that? Okay. Let's try to apply this. Y equals x squared. Is y equals x squared a function? Yeah. Okay. It's a parabola, which means it passes the vertical line test. I'm going to graph it. Okay, that wasn't a scribble, though. That was just a line. All right, does that look familiar? So these ordered pairs are like what? 2 squared is 4. 1 squared is 1. 0 squared is 0. -1 squared is 1. -2 squared is 4. Okay, so if I wanted to graph the inverse, what should I do? Are there any people that are really good spatial learners? I have a mental exercise for you. Can you flip this parabola over the red line? What would that look like? Yeah, that would look like a C. Okay, for those of us that aren't that spatial, we just flip the ordered pairs. So what would this be flipped? 4, 2. Okay, what about 1, 1 flipped? 1, 1. What about 0, 0 flipped? And -1, 1? Okay, that's different. That's here. And then 4, -2? Okay, I should really graph this more carefully. All right, let me be really careful here. So you were absolutely right. It looks like a C, right? This is something you should remember. Vertical things flipped become horizontal. Horizontal things flipped will become vertical. Okay. Y equals x squared. This is f of x. Is it a function? Is a function, right? Because it passes the vertical line test. What about the inverse? Is f inverse of x a function? Is not a function because it fails. Yes, vertical line test. Inverse of what? The inverse of it is this graph, which is not. Oh, that's a good question. You guys can answer that. What's the inverse of y is equal to x squared? Yeah, you flip the variables, right? X is equal to y squared. That's a sideways parabola, which is not a function. Any questions about this so far? So I want to be able to tell if the inverse will be a function before I flip it. Does that make sense? Before I flip it, how can I tell if the inverse is a function? Let's look at this vertical line here that it fails. It fails the vertical line test here, for instance, right? Because that purple line crosses the green graph twice. If I flip that line across, how does that correspond to the blue graph? This ordered pair should be 1, -1. If I flip it, it becomes what? -1, 1. And this ordered pair 1, 1 flipped becomes 1, 1. So vertical lines flip to become horizontal lines. Therefore, if my original function fails the horizontal line test, the inverse will not be a function. Does this thought process make sense? Okay, let's do the quick examples. Is this a function? Yes, passes the vertical line test. Is the inverse a function? No, fails the horizontal line test. Okay, because this thing, if it's flipped, would look like, can I do this in my head?
Yeah.
Would look like this and fail the vertical line test.
Yeah.
How do you flip it? Everything's symmetric across this line.
Just say.
You don't have to, but yeah, anyway, it's gonna look like this. Okay. Horizontal line test, you can tell if it's a function. Okay, for a function to have an inverse, it must pass the horizontal line test. Okay, conditions for an inverse. A function f has an inverse function if and only if f is one-to-one function, or in other words, it passes the horizontal line test. Okay, so this one is a function, but its inverse is not a function. So we flip the order pairs. Order pair, for instance, 1, 3 becomes, okay, another way, is it increasing or decreasing function? So this first one, does it pass the vertical line test? Does it pass the vertical line test? Yes. So it's a function. Does it pass the horizontal line test? This one, we're going to say yes. Okay. So, yes, the inverse is a function. Okay, this next one, is the inverse a function? No. We say it fails the horizontal line test. The inverse is not a function. Why do we care? Why do we like functions? What? Yes. Each input has a determined output, so you know what you're getting. If it's not a function, you don't know what you're getting. What that means is we can solve equations more simply if you know what you're getting. So why do we care about? Do you know what this graph, the function is? F of x is equal to x cubed plus some number. Let's just say plus 2. Okay, so if it has an inverse, y is equal to x cubed plus 2. What that means is you can flip these variables. I didn't flip it. X is equal to y cubed plus 2. And when you solve for y, you're not going to get any funny business that happens. So I can subtract 2 from both sides. So what I mean by that is when I take the cube root, let's say the cube root of both sides, I'm guaranteed to get a function. So that means cubics have inverses. They have cube root inverses. So now if I have a cubic, I know that's one way I could solve such an equation. Just take the cube root. Things that have inverses help us solve equations. Okay, straight lines. Do straight lines have inverses that are functions? Yes. So we'd say yes, the inverse is a function. Can you think of any straight line that does not have an inverse? Horizontal line. Good. A horizontal line, y equals 3, for instance, does not have an inverse because, well, the inverse would be a vertical line. This is the only type that fails the horizontal line test. Okay, this is what we're going to talk about in chapter 4, is exponential functions. Notice that this is increasing from left to right only. And we'll say it has a horizontal asymptote here at y equals 0 is an asymptote. Okay, so over here, there's no asymptote to the right. So this goes to the right forever and up forever. Okay, so what gives it away that this has an inverse that's a function? The horizontal line test. Also, it's increasing only. Going left, it just goes up and up and up forever. Okay, so that means that it has an inverse. Let's graph the inverse. So let's plot some ordered pairs here. Maybe this ordered pair here is 0, 1, 1, 2. Any others? 2, 4, negative. Okay, so this graph isn't great. It should only get close to the line, but never touch the x-axis. It's forever getting closer to the x-axis. Unfortunately, this line is thick, so it looks like it touches the axis, but it doesn't. Do you believe me? Let's do this on Desmos. Y equals 2 raised to the power of x. Okay, so over here on the left, it looks like it touches, right? Does it? No, it doesn't. What about way to the left? Does it touch? No, it's an asymptote. So if I keep zooming in, wow. Is this going to work? We've reached the limits of Desmos. Yeah, it shouldn't touch. There should be a gap there.
Or do you think the line's sort of distorting?
Screenshot it? You like this? Okay. Why not? This is going to be meaningless. There's nothing's labeled.
It's like an optical.
Yeah, it looks a little bit squiggly, huh?
Yeah,
It shouldn't be.
it shouldn't be.
If you're interested in seeing why computers are bad at math, you should take numerical methods. Why are computers bad at math? They can never represent 1/3 in its entirety. The 1/3 is 0.3 repeating forever, but they have a finite amount of memory, right? So eventually it's going to truncate it. But if you do something like, let's say, 1/3 to the power of 1,000,000, it's going to round it to 0, even though we know it's not 0. And that's what's happening with this graph. It looks like it's touching the line, so we've reached the limits of the mathematical system. Okay, so we want to graph this inverse, flip the order pairs. So if I flip them, they become what? 1, 0. What else? 2, 1. 4, 2. Can you connect the dots? Okay, I connected the dots, but how's the rest of the graph look? Yeah, remember, it should be symmetric about this line, y equals x. As this left side gets further from that line, this should also get further from that line. And on the other side, remember that that horizontal asymptote should become a vertical asymptote. And I should approach it on the side. Okay, if you have any issues, just come up with a random point, like this point here, and say this distance from y equals x should be the same on the other side. And that should be another symmetric point. Okay, composition of inverses. Inverse means opposite, right? So that means if you compose a function with its inverse, they should cancel out. You told me about a few inverses, right? What's the opposite of adding 2? -2. So if I plug an adding 2 into a -2, they should cancel out and I should get x by itself. That's what this is saying. What's the opposite of dividing by 3? Multiplying by 3, right? And you can tell they're inverses because they cancel and I get x by itself. Does this idea make sense? You plug one into the other, you can check if they're inverses. Okay, do you think that these functions are inverses of each other? Yes? Okay, so how do we tell? We need to plug it in both ways. G of f of x. What is the f function? It is 3/2 x minus 6. And the g function is 2/3 times that input plus 4. Yes. So if we distribute this 2/3, we get x minus what? x minus 4 plus 4, and we get x. So does that mean it's inverse? Not necessarily, but probably. That's what we wanted. We now need to plug it in the opposite direction. F of g of x. In this case, g of x is 2/3 x plus 4, and the f function is 3/2 of that value minus 6. Okay, so if we distribute, we get 3/2 times 2/3 is 1. What's 3/2 times 4? Plus 6. So plus 6 minus 6 cancels, we get x. So at that stage, we can say, yes, f and g are inverse functions. Is it possible that one way cancels out to get x and the other way does not? That is possible. So you do need to check both ways. Okay. The next thing, this is the important skill, usually a test question, is can you find the inverse of a function? So we already talked about this, but this is outlining the steps. You change y for f of x. The next thing you do is you interchange all the x's and the y's. X is equal to what? Y minus 1 over y. Is everyone comfortable with that? I changed these values. Y's and x's. Okay, and what's the hard part? Solve for y. That's step 3. Get y by itself. Any ideas how we would get y by itself here? Yeah, we multiply y to both sides. The reason we do that is we really need to get rid of the denominator to isolate y. So we always want to get rid of fractions. Yx is equal to y minus 1. Now I have 2 y's. How do I get y by itself if I have 2 of them? Divide by what? I don't want to divide by y. I just multiplied by y. So I don't want to undo that and divide by y. Okay, there's a trick that you've probably seen before. I'm going to get the y's on the same side. So what's yx minus y? To get y by itself, we now want to factor the y. If there's more than one term with y in it, then you factor it. Y times what is equal to -1? X minus 1. And how do you get y by itself? Divide by x minus 1. Y is equal to -1 over x minus 1. So this is the inverse of function f. -1 over x minus 1. Any questions about this? Okay, what's the new domain here? X cannot be 1, but anything else is okay. Do you guys know how to graph this f function? The answer should be yes. You should be able to graph this really quickly based on the worksheet. It's reduced. What's the vertical asymptote? When the denominator is 0. When's that equal 0? X equals 0. Does it have a horizontal asymptote? The degree of the top and bottom is the same. So horizontal asymptote is the leading coefficients, 1 over 1. I have a horizontal asymptote here. The x-intercept is where? When the numerator is 0? Okay, so should look a lot like this. Okay, the next thing I want to point out, if we flip all the x and y values, think about the domain of function f would be -infinity to 0, union 0 to infinity. Everything but 0. Do you agree with that? This should correspond to the range of the inverse. So if I flip the x and y values, that means the y cannot be. Okay, using that same logic, can you tell me what is the range of function f? It should be the same as the domain of the inverse. So what's the domain of the inverse? negative infinity to 1, union 1 to infinity. Because we switched the x and y values, we're switching the domain and ranges. Switching x and y variables switches the domain and the range. Are there any questions about this? Okay, so I'm going to quiz you on a few things for this last example. Is this the last example? Yeah, okay. Is x squared minus 6x plus 2, is it a function? Ask the vertical line test. Is the inverse a function?
No.
No, it fails the horizontal line test. Is the inverse a relation? Yes, a relation is any collection of ordered pairs. So the inverse is a relation. What is the domain of H? Can I use this notation, domain of H? We've used this before, right? What's the domain of any parabola? Good. All real numbers, yes. What is the range of H? Okay, so you can go based on the graph, but if it's not graphed, you'd really like to find the domain of the inverse, because that's easier. Find the domain of the inverse. Find the domain of H inverse. That's usually easier, find domains. Okay, so we said the inverse is not a function. In math, we make up our own rules. We say, you know what? I'd like to just cut off part of the graph so that the inverse is a function. How could I just eliminate half the graph? I pick whichever side I find more useful. Maybe I find the right side more useful. And then I'll say, let me just chop off the left arm. Now I have something that passes the horizontal line test. And I can find the inverse. And the inverse is a function. So this is something that we're going to do. We're going to say where the domain is x greater than or equal to 3. Here's 3. So we're just saying we're looking at the right half of the graph. Half of the parabola. Okay, if that's true, let's find the inverse of that new thing. So the process, replace h of x with y. That's step 1. Step 2 is what? Switch the x and the y's. X is equal to y squared minus 6y plus 2. How do I solve for y if I have a y squared and a y term? If I have a y squared term and a y term, I'm not going to be able to factor because I have to make one side 0. I can't really factor that because I don't know what this is. Does that make sense? What's the next thing you would try? Okay, if I have a y squared and a y, this is called quadratic in form. What are other options for solving quadratic equations? Quadratic formula or completing the square? Which one would you like to practice? Okay, let's do completing the square. So to complete the square, I need to move this 2 to the other side. X minus 2 is equal to y squared minus 6y. What's this magic number I need to add here to make this a perfect square? I take the negative 6 and I do what to it? Divide by 2 and square it. So 9 was absolutely correct. Add 9 to both sides. Plus 9. Okay, I did that because now the right side factors into a perfect square. What is that perfect square? Half of the 6, y minus 3 squared. So then how do I get y by itself? Square root both sides. What's the thing I need to be careful of when I square root a perfect square? Yes, very good. Plus or minus the square root of x plus 7. We add 3 to both sides. 3 plus or minus the square root of x plus 7. Okay, so I have two options here. Y is equal to 3 plus the square root of x plus 7. Or y is equal to 3 minus the square root of x plus 7. Which one do I want? Because both of them together make the inverse. What I mean by that is both of them together make the sideways parabola. Do I want the top half or the bottom half? How can you tell? The domain of H, the domain of H is the range of H inverse. So I want the range. Which of these is greater than or equal to 3? The left one or the right one? Okay, this one is 3 minus something. This one is 3 plus something. Y is equal to 3 plus the square root of x plus 7 gives us something that's larger than 3. The square root is always positive. We're taking the positive root. So that's our answer. H inverse of x is equal to 3 plus the square root of x plus 7. We have to throw that one out. Okay, what is the domain of this? X plus 7 has to be greater than or equal to 0. -7. That's our domain of this inverse. So it turns out that I end up throwing out the bottom half of this graph. Oh no. And I keep the top half.